Today I am going to discuss about the unit for overhead line insulators. The transmission line are classified into two types. One is for the overhead system, another one is for the underground cable. In underground cable, all the conductors are laid in the trench, but in overhead system, the material required for one is for the supporting structure, insulator, cross arms, so on, etc. In underground cable, we can use the limited operating voltage up to 66 kV. Economically, it is satisfied. Beyond 66 kV, that is, we can use up to 132 kV also. Economically, it is not satisfied. But in overhead system, we can use 230 volt, the single phase system, 2 wire, up to 765 kV system. That is, today we are discussed about the overhead line insulator. That is in the overhead transmission line system, how the insulators are used. That the first topic, requirements of line supports. That is, the main function of the line support is to support the conductor and also capable to withstand the load due to insulator. Here, the major requirement of the line supports, the first one is the mechanical strength should be good, withstand and weight of the conductor and wind load, etc. Here, if the mechanical strength is good, man, it can be withstand for the weight of high weight of the conductor. Here, the two weight is there. One is for the conductor weight, another one is for the wind weight. The conductor weight is presented vertical downwards, and the wind weight is presented for the horizontal. Another one, the supporting structure, the weight it should be light in weight. Suppose if the supporting structure, the weight is increased, means the transportation is difficult and erection is also difficult. And the cost, it should be lower cost, that is the cheaper in cost. Once the button is presented here, the supporting structure, conductor, insulator, in power system, one condition is there. That is, we need to satisfy for the consumer under two parameters. One is for the quality, another one is for the quantity. In a power system, we need to satisfy for the consumer under two parameters. One is for the quality, another one is for the quantity. The quality means we need to supply the consumer an uninterrupted power supply without load fluctuation. This is the quality. Quantity means we need to supply at reasonable price, that is the per unit cost. Here, the supporting structure, the cost is increased, means that button is presented to the consumer. We need to consider all the parameters, that is, we need to satisfy for the consumer, that is the supply, quality, and then quantitative power. If the conductor cost increases, the insulator or cross arm or supporting structure cost increases, that button is presented to the consumer. That is, we are selecting the supporting structure, the cost it should be lower value. And we are choosing the supporting structure, the maintenance is also less, that is the lower maintenance. Actually, here the supporting structure we are used for wooden pole, steel pole, RCC pole, PSCC, and then steel tower. That will be discussed elaborate in the next slide. Here, if you go for the steel pole, here the maintenance required is more. Regularly, we need to apply for the painting, or else due to the corrosion, the lifespan it should be reduced. That is, we are choosing the supporting structure. The maintenance is also very, very less. And another one, the chosen supporting structure, the lifetime it should be more. That is a long lifespan. That is 40 to 50 years or more than 50 years. Once we are erected the transmission line and then distribution line, that is the lifetime it should be 50 to 60 years. That is the supporting structure we are chosen for poles or towers. And for looking, it should be good in shape. For looking, it should be good in shape. And another one, easy accessible for painting and erection of line conductors. At the time of installation, we are chosen the supporting structure, it should be accessible easily. That is either RCC pole or towers, RCC pole or towers. And the steel towers, we need to apply the painting either 5 years once or 10 years once. Once the corrosion is formation in the tower, the lifetime it should be reduced. These are the various requirements of the line supports. Before erecting the transmission then distribution line, we need to consider all the parameters. And the next one, types of line supports. Actually, the supporting structure we are used for poles or towers. For distribution purpose, we are chosen for poles. For distribution purpose, we are used for the poles. For transmission purpose, we are used for towers. That is the distribution line. LT line we are used for the pole, and HD line we are used for the towers. That is up to 33 kV. Up to 33 kV we are used for the poles, and beyond 33 kV up to 765 kV we are used for towers. That is 66 kV, 132, 220, 400, and then 765 kV we are used for the towers. Again, based upon the operating voltage, the structure should be different. For 220 and then 400 and then 765 kV in the towers, they are used for the double circuit. That is, in towers, this is like that the tower is available. Now only this is nothing but the R phase, Y phase, and then B phase. This is for the single circuit. The double circuit in the sense, it is R phase, Y phase, another one is for the B phase. This is R, Y, B, and another one is for the R dash, Y dash, and then B dash. The top conductor is called as the ground conductor or earth conductor. The top conductor is called as the ground conductor or earth conductor. Now, how we can identify that is ground or earth conductor means, in this the ground or earth conductor without insulator is there. Remaining the phase conductors, the insulator is available. And the insulators are classified for 4 types. One is for the pin type insulator, suspension or disc type insulator, strain type insulator, another one is for the shackle insulator. For transmission line, they are used for the 2 insulator. One is for the pin type insulator, another one is for the suspension type insulator. In pin type insulator, that is, we can use for the 11 kV to up to 33 kV. That is, it is only preferred for the distribution purpose. Beyond, if the 11 kV or beyond 33 kV, economically it is not satisfied, and the weight is also increased, the size is also bigger size. That is, beyond 11 kV means they will be go for the suspension or disc type insulator. Each disc capacity is called as 11 kV. Each disc the capacity is 11 kV. Based upon the operating voltage, connected for n number of discs in series. Connected for n number of discs in series. For example, you can take 33 kV. How many number of discs are connected in series? That is, the 3 discs are connected in series. Suppose if the operating voltage is 66 kV, they are connected for 6. No. If the operating voltage is 132 kV and 220 kV, how we can use for number of discs are connected in series? That is, one formula is there. We can take the phase voltage. We can take phase voltage by individual disc capacity. Phase voltage by individual disc capacity. Individual disc capacity plus 1 spare disc or additional disc. Plus 1 spare disc or additional disc. Like that, we can calculate how many number of discs are connected in series. For 33 kV, directly we can take for the 3 discs are connected in series. If 66, 132, 220, 400, and 765 kV, directly we can't connected the by 11. That is the phase voltage. For example, here you can take 440 kV. How many number of discs are connected in series? For example, we are considered for the 440 kV transmission line. That is 400 by, here we need to take for the phase voltage. That is 400 by √3 by the disc capacity. Here the individual disc capacity, the each disc capacity is 11 kV plus 1 spare disc or additional disc. We are simplifying, that is, for us we are getting for 22 discs are connected in series. The round of the digit. If you are getting 0.5, round off the next higher value. If less than the 0.5 value, you can round off the lower value. That is how we can choose on the number of discs are connected in series in over a transmission line. That is based upon the line capacity, that is either 220 kV or 400 or 765 kV. Here we need to consider for the phase voltage by individual disc capacity plus one additional disc or spare disc. Here we are taken the example is for 400 kV transmission line, that is the phase voltage 400 by root 3 by the disc capacity is 11 kV plus one additional disc or spare disc. We are getting 22 discs are required, that is 22 discs are connected in series. Like that we can calculate 220 kV, 132 and then 765 kV. Now here the types of line supports. The line supports are classified for 4 types. That is generally in the overhead transmission line, conductors are supported rods is known as the line supports. That is, it is classified for wooden pole, steel pole, RCC pole, PSCC pole. Another one is for the towers. RCC pole in the sense reinforced cement concrete pole, pre-stressed cement concrete pole, that is represent for the PSCC pole. Wooden pole, that is used up to 20 kV, steel pole used up to 33 kV, reinforced cement concrete pole used up to 33 kV, that is RCC pole, and PSCC pole, that is pre-stressed cement concrete pole used up to 11 kV. Towers, that is from 33 kV, that is beyond 33 kV up to any operating voltage, that is up to 765 kV. The towers are used for 66 kV, 132, 220 kV, 400 kV, and then 765 kV. The first one, that is wooden pole, the operating voltage, the capacity up to 20 kV. That is the practically for us the operating voltage is available for the 11 kV. That is up to 11 kV we can use for the wooden pole. That is the wooden poles are mainly used for low voltage applications, that is used for the distribution power in rural electrification. Distribution power in the rural electrification. That is, these the wooden pole, they are used only, preferred only for the distribution purpose, that is 3-phase 400 volt 4-wire system or 3-wire system, 4-wire or 3-wire system, and another one is for the single phase 230 volt 2-wire system. Single phase 230 volt 2-wire system. And these wooden poles, the availability is huge quantity of available wood is there, we can access easily. And why they are preferred wooden pole means recently at present also few of the places they are used for the wooden pole. Why they are used means, for example, you can take some of the rural electrification, only 5 or 10 consumers are there. 5 or 10 consumers are there. In that the particular area, the transmission line is not available. The transmission line is not available. There we need to supply to the consumer electricity. Again, there we are preferred for the either steel pole or RCC pole, and the conductor, insulator, cross arms, that is the burden is presented to the electricity board. Here these consumers on an average they are utilized per month 50 to 70 units on an average per month, or the maximum they are utilized 100 units. Those consumers they are used only for the light load, that is one tube light or tungsten filament lamp, TV, they are not used for the refrigerator, greaser, so on, etc. There the demand is also very less. On an average per month they are consumed less than 50 units or less than 100 units. How much they are paying the EV bill per month? That is less than 100 rupees or approximately equal to the 100 rupees. Now, but the electricity board, they need to supply to the electricity to those consumers. Again, they need to erect for the distribution lines, again step down transformer and the conductor insulator. That is the button is presented to the EB board, electricity board. Those areas they are preferred for the wooden poles. That is the wood is available plenty, the cheaper cost cast, and at the time the burden is reduced to the electricity board. What are the advantages using for the wooden pole? That is, wooden pole, the cost is very less and available in the free of cost. That is easily available, and the insulation property is also good. This widely used for the distribution purpose in rural area. Wooden poles are the maximum they will be preferred only for the rural electricity purpose. That is only for the distribution purpose. That is distribution purpose in the rural electrification. Maximum they will be preferred for the single phase. That is single phase 230 volt 50 Hz. Single phase 230 volt 50 Hz. Beyond also we can use it, but the insulation problem is there. And the major drawback by using the wooden pole, that is the span length is limited span length. That is from one supporting structure to another supporting structure, the span length is less than 50 meter. That is the span length is less than 50 meter. This is the one drawback. And another one, lifespan of the wooden pole is very less. That is less than 20 years or up to 30 years. Less than 20 years or up to 20 years. And another drawback, it is not used for voltage higher than the 20 kV. That is, we can use up to 11 kV. Beyond, we can't be able to use for the wooden poles. And it is regular inspection is required. In the rainy season, the wooden poles are damaged due to the high wind pressure. If the wind pressure is more, means the wooden poles are broken into 2 or 3 pieces. That is all the conductor into laid on the ground. At the time affected for the surrounding living organism, that is animals, human beings, so on, etc. And some of the times the bottom of the wooden, the corrosion is taken place. That is the wooden are damaged. That is regular inspection is required in the wooden poles. That is every monthly once or monthly twice or 3 months once. And one more thing, in the rainy season, regularly we need to observe the visit the inspection. This is the major drawback. And the mechanical strength is also less. That is, once the weight of the conductor is increased, the wooden poles are not withstand. That is, it is not affected withstand for the mechanical strength. Here the two weight is presented. One is for the vertical weight, that is vertical downwards, that is conductor weight. Another one is for the horizontal weight, that is wind velocity. If the weight is increased, means the wooden poles are not withstand. That is, it is not good for the mechanical strength. These are the various advantages and disadvantages of the wooden pole. Maximum, the wooden poles they will be preferred for the rural electrification, that is for the distribution purpose. That the operating voltage we can use up to 20 kV, but the practical we can use up to 11 kV. Here the wood is available for plenty of quantity, available in the free of cost. It is we can use for the wooden poles. The next one is for steel pole. That is the steel pole we can use up to 33 kV. Steel pole we can use up to 33 kV for both transmission as well as for the distribution purpose. What are the drawback in the wooden pole that overcome by using the steel pole? Here, what are the drawback? The span length is very less in the wooden pole, that is less than 50 meter, and lifetime of the wooden pole is also less, that is less than 20 years or up to 20 years, and we can't able to transfer higher operating voltages. We can use up to 20 kV, but in the steel pole we can use up to 33 kV, and the regular inspection is required. But comparing to the wooden pole, in steel pole, the inspection is less. But we need to apply the regular painting. We need to apply the regular painting. The mechanical strength is not good in the wooden pole, but comparing to the wooden pole, in steel pole, the mechanical strength is good. Here, the steel poles are classified for 3 types. One is for tubular pole, the second one is rail pole, and the third one is rolled steel pole. Rolled steel. This is the steel pole. What are the drawback in the wooden pole that overcome in the steel pole? Again, the steel poles are classified into 3 types. One is for tubular pole, the rail pole, another one is for the rolled steel pole. Here the steel pole, it is used for up to 33 kV, that is both transmission as well as for the distribution purpose. That is for distribution side, the height of the steel pole is 9 to 11 meters. For distribution side, the height of the steel pole is 9 to 11 meters. For transmission side, the height of the steel pole is 11 to 13 meters. 11 to 13 meters. That is used for transmission purpose, in the sense they are used 11 kV and then 33 kV. The supporting structure, the height is from ground level to the conductor level, that is 11 to 13 meters. Here the advantages is the mechanical strength is good. It can be withstand for some amount of the weight of the conductor. And the second one, the lifetime of the steel pole is more comparing to the wooden pole. Here in the steel pole, the lifetime is 40 to 50 years. But we need to apply the regular painting. We need to apply the regular painting. That is the inspection is required. The lifetime it should be 40 to 50 years. This steel pole we can use up to 33 kV operating voltage. That is used for transmission purpose as well as for the distribution purpose. For distribution side, that is single phase 230 volt, three phase 440 volt. On the transmission side, we can use 11 kV and then 33 kV. Next, the span length is more. That is, the span length is 50 to 80 meters. That is the span length, one supporting structure to another supporting structure, we can use 50 to 80 meters. 50 to 80 meters. That is in the steel pole. What are the drawback in the wooden pole that overcome in the steel pole? That is, the major drawback in the wooden pole is mechanical strength is not good, but in the steel pole the mechanical strength is good. And another one, in the wooden pole, the span length is less than 50 meter. In steel pole, the span length is 50 to 80 meter. And the lifetime of the wooden pole is 20 years. But in the steel pole, the lifetime is 40 to 50 years. But the painting is required. This is the drawback in the steel pole. The steel pole are classified into three types. One is for the tubular pole, rail pole. Another one is for the rolled steel pole. For all these things, that is used for transmission as well as for the distribution purpose. Here, for distribution side, that is the steel pole, the height is 9 to 11 meters. That is, we can use 3-phase 4-wire system or 3-phase 3-wire system. For transmission side, 11 kV and then 33 kV. The height of the pole is 11 to 13 meters. And the next one is RCC pole, that is reinforced cement concrete pole. It is used up to 33 kV. That is, what are the drawback in the steel pole that overcome in the RCC pole, that is reinforced cement concrete pole? In steel pole, we need to apply the regular painting. That is, the inspection is required. Apply the regular painting. In the rainy season or due to the moisture particle, in the steel, the corrosion is occurred. But in the RCC pole, that problem is not arises. In recent years, these RCC pole are mainly used for distribution as well as for the transmission purpose. This RCC pole, they are used for both transmission line as well as for the distribution line. That is, in RCC pole, they are used for single circuit as well as for the double circuit, and the span length is 80 to 200 meter. 80 to 200 meter. But in the steel pole, the span length is 50 to 80 meter. But in RCC pole, the span length is 80 to 200 meters. And this they are used for single circuit as well as for the double circuit. The advantages of the RCC pole is the mechanical strength is high comparing to the steel pole. The mechanical strength is greater, the mechanical strength, and the lifetime is also more. It is, we can use up to 100 years or more than 100 years also. And the looking is the good and require the little maintenance. That is, the maintenance is very, very less. It is not required for the regular inspection, not required for the regular painting. And the insulation property as compared to the steel towel is also good. That is, the steel pole comparing to the reinforced pole, the insulating property is good. And the drawback is the transportation is cost is high in the RCC pole, because comparing to the steel pole, in reinforced cement concrete pole, the weight is more. That is, the drawback is the transportation is cost is more. The transportation cost and erection of the RCC pole is also difficult due to the overweight. Due to the overweight. These are the drawback of the RCC. In RCC pole, that is reinforced cement concrete pole, this is used up to the 33 kV, but recent years they are preferred only for the RCC poles. They are not preferred for the steel poles. They are preferred for the RCC pole. In RCC poles, that is comparing to the steel pole, here the lifetime is more. That is up to 100 years or greater than the 100 years, and the span length we can use for 80 to 200 meter. But the steel pole, the span length is 50 to 80 meter. But the RCC pole we can use 80 to 200 meter span length. In recent years, they are preferred for RCC pole for both transmission as well as for the distribution purpose. The transmission is they are preferred for 11 kV and then 33 kV. In RCC pole, they are used for double circuit also. That the advantages is the mechanical strength is good, the lifetime is more, and we stand for the longer span length, and the insulation property is also good. The maintenance required is very less. Only the drawback is the transportation, the cost is more, and the erection of the transmission line is somewhat difficult. And PSCC pole, that is pre-stressed cement concrete pole. What are the drawback in the RCC pole that overcome in the PSCC pole? But here we can use up to 11 kV. We can use up to 11 kV. Here in the pre-stressed cement concrete pole, the supporting structure, the weight is less. That is, the transportation, the cost is minimum, and the erection is also easy. The erection is also easy. But that is the later light weight and the handling is also easy. But this type of poles we can use for 11 kV LT line. That is used for the low tension line. Low tension line. This is they preferred only for the distribution purpose. Distribution purpose. What are the drawback in the RCC pole that overcome in the pre-stressed? Here in the RCC pole, the drawback is two things. Due to the overweight, the transportation is difficult, and the transportation cost is high, and the erection is also difficult. So that overcome in the pre-stressed cement concrete pole. That is, the pre-stressed cement concrete pole, the lighter in weight. Due to that, the transportation is easy, and handling and erection is also easy. But this is the preferred up to 11 kV. That is LT line. And the last one is for tower. Generally, what are the drawback in the wooden pole, steel pole, RCC pole, PSC pole? Those overcome in the towers. Those overcome in the towers. But in wooden pole, the steel pole, RCC pole, pre-stressed cement concrete pole, limited span length. Limited span length. That is, in wooden pole less than 50 meter, steel pole 50 to 80 meter, RCC pole 80 to 200 meter, and pre-stressed cement concrete pole up to 100 meter. But in the tower, there is no limit. That is, in the towers, there is no limited the span length. And another one, in longer transmission line, we can use for the operating voltages, higher operating voltage. But in wooden pole, we can use up to 20 kV, that is up to 11 kV. In steel pole, up to 33 kV. RCC pole, up to 33 kV. And pre-stressed cement concrete pole, up to 11 kV. But in the towers, we can use up to 765 kV. That is from 33 kV to up to 765 kV. That is 66 kV, 132 kV, 220, 400, and then 765 kV. We can use any operating voltage level. We can use any operating voltage level. Here, mechanical strength is good. Mechanical strength is good, and the lifetime is more. The longer lifetime, that is up to 170 years or 180 years, that is more than 150 years, and the span length is more. The span length is more, that is greater than the 200 meter. You can use up to 500 meter also. But the construction it should be different. The structure, the position is also changed, and it can be withstand for any climate conditions. The towers, it can be withstand for any climate conditions, any temperature level or any climate conditions. and the reliability of the supply is more. Operating voltages, it is not the constant value. We can use for the any operating level. These are the various lines supporting structure. It is classified for the 4 types. One is for wooden pole, steel pole, RCC pole, pre-stressed cement concrete pole, tower. But at present, they are preferred for the 2 things. One is for the RCC pole, they are used up to 33 kV. That is for distribution as well as for the transmission purpose. The transmission means 11 and then 33 kV. Beyond 33 kV, they are preferred for the towers. That is 66 kV, 132 kV, 220, 400, and then 765 kV. They are preferred for the towers. They are preferred for the towers. Here, in the towers, again, the single circuit as well as for the double circuit is there. The double circuit, they are preferred for the 220 kV, 400, and then 765 kV. In this, the class we are discussed about what are the requirements of the line supports and types of the line supports and the basics of the insulator. How we can choose for the number of discs are connected in series in over a transmission line. That is the phase voltage by individual disc capacity plus one additional disc or spare disc. And the requirement of the line supports. Before erecting the line supports, we need to consider the following parameter. The supporting, it should be withstand for the high mechanical strength, and both one is for the weight of the conductor, another one is for the wind weight, and the weight it should be lower value, and the cost is less. Maintenance is also lower maintenance, the longer life, and easy accessible at the time of erection, at the time of painting. These are the various requirements. And types of line supports is classified for 5 types for both distribution as well as for the transmission purpose: wooden pole, steel pole, RCC pole, PSCC pole, towers. That is, recent days they are preferred only for the 2 things. One is for the RCC pole for distribution as well as for the transmission purpose. That is up to 33 kV. That is 11 and then 33 kV. Remaining all they are preferred for the towers.